Frank Fitzgerald, Product Manager for Tyco Electronics, Raychem products, and the cable accessories. For those of you who don't know what cable accessories are, there's a couple examples right behind me. The ones on the left are 750 kc mil 25 kV cable. There's 3 cables there, the black things, and they're feeding this entire industrial establishment of about 7 or 8 factories and several other residential areas, all through those 3 cables. The little gray bits on the end of them are cable accessories. Those are actually terminations. The accessories on the right, the pole on the right, has 3 smaller cables, and those are feeding our actual facility right here. So if those go out, our entire facility goes out. Cable accessories are somewhat taken for granted, but they are a critical part of the distribution system. Today we're going to talk about the proper installation of those terminations and some splices. We're going to talk about how they are tested and meet some of the people who really know how to put them on and teach other people how to put them on. So right now we're going to go inside the plant and meet these people. Come on. This is one of the combination labs that we have at the Raychem, North Carolina facility. This one we have some testing going on over here. It's a good idea to mind those signs because some pretty dangerous things happen inside that cage. But primarily this lab is the place where we teach our customers how to install our products and give them a chance to install them so that they learn the techniques for installing, in the past, heat shrinkable products, and hopefully in the future some cold applied products. This is one of the somewhat more complex products that customers have installed. This is a heat shrinkable Y-splice. We're not going to show you that today, but we are going to show you some other products. And we're going to get with Dennis Lynch. He's the master cable splicer. He's been doing this for 40 years. He's currently the medium and high voltage cable accessory product manager for North America. So I'm going to go talk to Dennis right now, see what he's up to.
Frank, how you doing?
Good.
All right.
This is Dennis Lynch.
Hi.
He's the medium and high voltage cable accessory product manager for the Americas. Dennis is going to show us how to do a heat shrink cable splice right now on 15 kV copper tape shielded cable.
In here we have the stress relief material. This moisture sealed envelope.
And a special bag to keep the moisture
prevent
out.
Moisture getting at the material. What you have to do with the long strip is remove one side, the side with all the writing on it. Remove that and then roll it up in a nice tight roll. And then apply it over the connector, filling in these gaps at the insulation cutback. Build up to a little bit over the diameter of the cable insulation and go onto the insulation about 1/4 inch. And this stuff, you can stretch it as much as you like so you can make a nice, tight, neat installation.
So you're just filling in any voids, Dennis?
Yeah, this is a stress relieving material and a void filler so that there are no air voids trapped under the heat shrink tubings.
But that's not semicon, right?
No. So that's about the right diameter. You see it's about the same, just a little over the diameter of the cable insulation. Then we use the same material, these little angle cut pieces. Remove the backing. Remove both backings from that because it's so small. And we have to fill in this little step at the end of the semicon because otherwise, if we didn't, when you shrink the first tubing on, you get air trapped there. A ring of air would be trapped, and that air, when they energize the circuit, it would ionize and discharge, and then eventually, with the discharge, it would damage the cable insulation, and eventually you get a failure. So we just fill in this little step. Don't need to put too much. Go 1/4 inch onto the semicon and 1/4 inch onto the insulation, and that's sufficient. Do that at both ends. next step is to put a little bit of this discharge control compound, which is basically a highly refined silicone grease, and we just put a thin smear on the yellow mastic, and that is to prevent the first heat shrink tube we put over. We don't want it to stick to the mastic, because in summertime, when the weather's hot, this mastic can get a little tacky. So we don't want to the first tube to stick to it. I should mention, prior to installing the connector, this is just a cable sample as you can see, but in reality in the field, prior to installing the cable connector, you must put the tubes over the cable. They can nest all 4 tubes together like so. This is the rejacketing tube, and put them all over the cable together, or these 3 tubes can go one side and the rejacket on the other side. This first tube, this black tube, is a stress control tube, and you centralize it between the cable jacket cuts. This cable we're using here is a copper tape shield, but this splice is good for uni shield, wire shield, and copper tape shield cable, or lead sheath cable even. So the first tube, you just eyeball it, centralize it between the jacket cuts, you know you've got it in the right position.
And that's not semicon, right, Dennis?
Not semicon,
Definitely
no.
not semicon. It looks like it, but it's not.
But it is not. You have to be aware that you must get the heat around the full circumference of the tube, otherwise it doesn't shrink correctly. Adjust the flame.
It's important to use the right torch too. If you use the wrong torch, like a Bernzomatic torch with a pinpoint edge, you'll burn the tubing. You have to use a torch that has a bushy flame like that.
So you see I've repositioned the flame to point down the tube now, and now I'll reposition it again to do the ends. And go back to the center once it's shrunk on that side. Be careful not to start to shrink these tubes over this side. And then finish it off with a little flame brushing just to make sure you've got it properly recovered. And that's the first tube completely installed. That tube is followed by this red insulating tube, which is positioned in the same position. They're approximately the same length, and you shrink it in the same way. Keep the flame moving so that you don't scorch the tube. However, if you do scorch it, we don't recommend that you do scorch it, but if you do happen to scorch it, all you do is just clean that scorched area with some solvent, and if it's really badly scorched, you can abrade the scorched area away. Flame brush it. But if you hold the flame on it in one place too long, it will scorch, as I'll show you. Now you can see it's burned. But if you let it cool off and take some solvent, that will wipe away, and as I said before, if it's badly scorched, you can just abrade it with a very fine abrasive. But prior to putting on the last tube, we install the internal moisture seals with this red sealant. Put it on the cable semicon, and you put sufficient to bring the diameter of the sealant to the similar diameter of the red tube that's just been installed. The red inner layer is insulating, the outer layer, the black layer, is conductive. And the 2 layers are co-extruded, so there's no chance of any pockets of air between the 2 layers. If you have air between the 2 layers, you get ionization and discharge, and it's something has to be avoided. So you put this over, and you see it lands on the sealant because it's a couple of inches longer than the previous 2 tubes, and you shrink it down onto the underlying tubes and the sealant, and you get a perfect moisture seal at these ends. So should any damage occur to the cable jacket up the line somewhere and moisture comes down under the cable jacket, it would reach this sealant and would go no further. It wouldn't get inside the inner working part of the splice. This tube is a little thicker, so it takes a little longer to shrink.
Then it's the outside of that's conductive?
Yes, it is.
So that's like the shielding of the cable?
Exactly.
So you've rebuilt the cable?
Exactly. We'll put copper mesh shielding overall so that will connect the outer layer, this conductive outer layer, to the cable semicon. So and shielding.
You got a stress control inside.
Yep.
First there was void fillers, then you put a stress control, and you put insulation and conductive.
Right.
I got it.
But all these components are factory engineered. So if you follow the steps that you'll see in this video that I'm doing, a quality installation will be assured. We do the flame brushing. Now we install the ground braid. You have to make sure that this braid makes contact with the copper tape. Some people, when they install this, they put the roll spring on first, like so, and then the ground braid, because it's easier to install if you do it that way.
That's right.
However, this roll spring is not a great electrical conductor, so not like the ground braid, which does definitely have to make electrical contact with that copper tape shield.
And that ground braid's copper?
Yeah.
Tin coated copper?
Tin coated copper wires, very fine wires. Just give it a little twist to tighten it up. Little bits of adhesive back copper tape, just to ensure that the roll spring stays in place. So, 2 layers of the roll spring over the braid, fold the braid back, and then the remainder of the roll spring overall.
And that just makes the shield continuous across the joint, Dennis?
Yep. Then we have the copper mesh. You can cut this excess braid off or just leave it in place and tie it down with the copper mesh. This copper mesh is for personnel safety. Should anybody unfortunately spike the splice, the voltage will go through this mesh to ground instead of through the spiker's arm to ground. That's the idea of it. And then tie it off with a half hitch. Then we have to get some abrasive strip, some solvent. What you do is solvent clean the cable jacket, make sure there's no grease there, and then take an abrasive strip and rough the jacket up to take the shine off it. This is a 120 grit, and just rough this jacket up, take the shine off it. That makes sure you get a good moisture seal.
And this is to replace the jacket, Dennis?
This is replacing the jacket.
Okay.
And to shrink it in the same manner that I shrank all the other tubes.
Now a lot of these tubes look the same. At least they look black, and
yeah,
they all look kind of black and similar, but they do have different functions. And this one is used primarily to replace the jacket and provide a little bit of mechanical protection for the joint. And you can tell this one shrinks a lot faster than that last one you installed because it's thinner, is that right?
Because it's thinner, right. And you'll notice here where it's shrunk down that the heat-activated sealant has oozed out of the end. That's a good sign that you've installed it correctly.
See, what you can't really see is that Dennis is heating this up all the way so he doesn't have any flat spots or ridges. And you can tell, you can see it with your eye and you can feel it with your hand. Though I would recommend don't touch the splice right now. So that's it, Dennis,
That's it. That's the 15 kV inline splice.
I'm standing in the middle of the AC test cage at our North Carolina facility. This is where we subject the cable accessories to some of the electrical tests. To my left is an 800 kV impulse generator. This mimics the effect of lightning or switching surges on cable accessories through a bunch of capacitors that fire at a certain sequence. It's all done electronically. Don't worry, it's all quite safe because it's grounded, as you can see with this grounding stick here. Behind me, in this blue cube, is a 250 kV AC transformer. We use this for AC voltage withstand as well as partial discharge measurement. It has some very strange looking corona rings up on the top. That's to eliminate any noise. And as you can see, it's safely grounded here. But what we're going to use this piece of equipment for today is to answer a couple of questions that we get all the time on cables. And that is, why do you have to use a cable termination? If you strip a high voltage cable and take the semicon back, you get a condition that looks like this: a semicon back here and insulation right here. Well, I'd like to show you what happens if you don't put a cable termination on this and energize it at any substantial voltage above 5,000 volts. What we've done here is made a cable. It doesn't look like a cable yet, but let me explain the parts. This is a tube like this, just a piece of steel conduit, and we have shrunk some insulating tubing on this piece of steel conduit, a couple layers, and then right here we put a piece of conductive tubing. This is a piece of the conductive tubing that we've shrunk on here. So that's what we have, a conduit underneath, some insulating tubing, and a semiconductive tubing shrunk on top of that, and this is grounded through this mesh right here. So now, for all intents and purposes, this looks like a cable. The conductor is underneath, you can't see it, but that's what we have right here. This is the same thing as the insulation, and this is the same as the semicon cutback. What we're going to do is energize the conductor, or the conduit in this case, and we're going to see what happens right here at the semicon cutback to show you what you can see as discharge. It's electrical discharge, and it will start forming right here as a very subtle blue haze, and eventually we'll have quite a spectacular show here. So let's see what we can do with it. We're going to take off the grounds. I'm going to get out of the cage so it's safe, and then we're going to energize this and see what we can see. Thanks. Let me explain a little bit about what was happening during that display. You started seeing some corona right here. This is the conductive tubing, and we started seeing the air break down right here. Air breaks down at about 21.6 kV per centimeter, and you started seeing air become a conductor because the voltage got so high along the surface right here that we exceeded 21.6 kV per centimeter, and all of a sudden air became a conductor. When that happened, we had a blue glow around here, and eventually we started getting some sparks. Now, it's high voltage all the way to the end, but you only saw that activity right here, and that's because there isn't any voltage drop out here. It's all the same high voltage. But when you get right here, you got to go from high voltage to ground in a very short distance, and that's what electrical stress is. The volts divided by the distance, and if that exceeds 21.6 kV per centimeter, air becomes a conductor. Another good example of that is lightning, and that's really not a very nice situation. Anybody that's ever encountered lightning knows that that's bad, very bad thing to have. So what we're going to do right now is show you the effect of putting a termination on the end of this artificial cable. This is a stress patch, the same patch that we use in the cold applied termination, the TFT. It's a zinc oxide stress relief material. What I'm going to do right now is put that on the end of this phony cable, semicon cutback, and wrap it around like we would as though it were a real cable. And now I'm going to take this, which is the holdout, I'm going to install it on the end of the cable and make a termination on the end of our artificial cable. Okay, what we've just done is installed the termination on the cable, the phony cable, and now we're going to run the voltage up and see if this makes any difference. Today Dennis is going to show us a heat shrink termination, Raychem HVT, and that's been on the market about 35 years, hasn't it, Dennis? Since the 60s?
Something like that, yeah. Late 60s,
so
mid-60s.
Dennis is going to walk you through the installation of this thing, but he's not going to show you the cable prep because he's already done that, and he's done an expert job here. So Dennis, take it away.
So the first step in this installation is to fill in the semicon cutback, because there's a little step there, and what we will do, we'll install this black tube, which is a stress control tube, and we'll shrink it down there. If you don't fill in the step, there would be air entrapped at the step, and when they energize the circuit, that air will ionize and discharge, and probably eventually you would get a failure at that area, because this is a high stress area at the end of the semicon cutback. So we fill it in with this yellow mastic we call stress relief material, which is a stress controlling material, and it goes 1/4 of an inch onto the cable insulation and 1/4 of an inch onto the semicon. You don't need to put the full strip usually, maybe you do on a larger cable, but that's all you need, just enough to fill in the step and get a nice taper down from the semicon down to the insulation.
Dennis, in some other kits, don't other manufacturers use like a grease or something?
Yeah, some manufacturers I've heard and seen, they fill in that step with a silicone grease, but
this is a little bit more robust and it stays there.
Yes, yeah.
Okay, Dennis, you just put the stress control tubing on there. What happens if you don't put a stress control tube there and didn't do anything at the semicon cutback?
Well, I have an example here where this is a 25 kV termination cable, and you can see the hole there. This is at the semicon cutback, or where it was sent in to me for analysis. They wanted to know why it failed, and I saw the hole, and it looks just like somebody shot it with a 22.
So if you don't put any stress control, you'll have a failure at that point.
Similar, yeah. Back to the installation now. This is the first tube to be shrunk. Normally a termination is upright, so we always start shrinking at this end of the tube and work our way along it so that no air gets trapped in there under the tube. And you have to make sure that you get around the full circumference of the tube to make sure that you get a symmetric recovery of the tube, and then just give it some little bit of flame brushing at the end, and you can see that it's nicely shrunk. There's no flat spots or cold spots anywhere, and that's a good installation. Next, we're going to install a moisture seal on the jacket, and to ensure that you get a good moisture seal, we like to make sure that the jacket doesn't have any grease or oil on it, so use this solvent ready to accept a nice moisture seal. You just dry off with the drying wipe, and then to further ensure that you get a good moisture seal, we just take the shine off the jacket with this abrasive strip. So you take this mastic red sealant, put 2 layers directly onto the cable jacket. Then you lay the wires back into the mastic. Make sure you don't cross them. If you cross them, that will give a path for some moisture to enter the termination. And then we put 2 layers on top. So what you have is a nice moisture block there. You made a sandwich of the sealant and the wires. Want to stay in place. Continue to the sealant onto the insulation. So the next step is to install the non-tracking tube.
And what do you mean by non-tracking? Is there something special in that?
Yeah, because you know when this termination's installed and you get in humid conditions or high pollution areas, or it's raining, the electricity wants to come from the cable lug down to ground, and the way it would do that is on the outer surface of this tube,
which could cause a track.
Yeah, it would cause electrical tracking and erosion, and you'd quickly lose it. This tube has is formulated so that it prevents that tracking. That's basically what we mean by non-tracking tube. We shrink it down in the same way that I did the stress control tube.
Dennis, that looks like it's too long. Is that a problem?
No, we trim it at the end. We make it a little longer than necessary.
So it's important to start that at the mastic, is that right?
Yep.
Okay. Remember, heat shrink tubings not only shrink this way or radially, they shrink this way, which is called longitudinal. And if you don't put it at a dimension that we call in the installation instructions, then you're not really sure where that shrinkage will happen. But since we have engineered these kits, we know that it could shrink lengthwise, and we take that into consideration in the design. So if it does shrink a little bit, it's not going to matter. And in this case, you can see there's quite a bit more at the end. And I assume you're going to cut that off?
Yeah.
Dennis will cut
make
that
sure
off.
this is nice, properly shrunk by giving it a flame brushing like you saw me do there. And then when that's cooled off, or even now, put a glove on, I can trim this tubing to the correct length. You can feel the lug underneath. Now, that's an indoor termination, and to convert it to an outdoor termination, we install what we call the rain sheds. There's a dimension given in the installation instruction from the bottom of the tube. Now these sheds, the only part that shrinks is the collar here, so we don't need to heat the outer part, just this collar. And there's a technique I use to do it. I shrink it sufficiently so that the collar just makes contact with this tubing, and it usually goes crooked, and then just when it makes contact you back the flame off and straighten it up, and then finish it off, as I will show you.
And you use a slightly softer torch too.
So you just straighten it up, make it nice and perpendicular to the termination. It's just for aesthetics, that's all, just makes it look nicer.
So you're just applying heat to this center
to the
port.
collar, and give it a little bit underneath.
Okay.
Like that. And this 15 kV, it has 2 rain sheds.
And there's a dimension in the instructions on where they go.
Dimension is given.
And again, you're getting it all the way around, right? So you heat it up all the way around.
If the, usually terminations are upright, and you might need to hold these with a little pair of pliers or something just to hold them in position until you get the collar shrunk onto the to the tubing.
And let that cool off, and it's ready to energize?
Yeah, it's ready to energize.
Okay. Well, thanks a lot, Dennis. We appreciate it.
My pleasure.
Okay.
Anytime.